So in our previous video, we tested the launcher, and we noticed that several times the launcher threw the ball towards the left, and we wanted to see if we could straighten that out. So we took a look at some different key components. You can see those in red. We have our 5/16 stop pin, or bolt, and our PVC cradle that holds the ball. Now currently what happens is you pull the bar back, and then the ball goes back with the bar, and you release the bar, and the ball travels forward with the bar, and then the bar hits the stop, but the ball continues on. So what we wanted to see if we could do is remove the pin and the cradle. And one of the reasons is that the pin can potentially be a pinch point, and it also has the effect of building up stress in a very specific point on the aluminum bar there. And that stress can work harden the aluminum. It actually changes the crystalline structure of the metal over time and causes it to be more brittle and can eventually cause it to crack. And so we were going to see if we could launch the ball using the same kind of technique that a football kicker would use. So the kicker would, there would be a guy holding the tip of the ball in place, and the kicker would wind up and then kick the ball. And instead of the ball traveling with his foot, he would instantaneously contact the ball that's being held in a certain point, and then the ball would release. So we thought it might be interesting to design a device that could hold the ball in place, like our kicker, like the guy that holds the ball in place for a kicker. So we thought maybe we could take a paper clip and bend it to create a device shown in purple here to hold the ball in place, and then we could remove the cradle and the stop pin and maybe improve the accuracy and longevity, wear, and maybe even the safety of the device. So we started with the ball. We put it in its location. Then we took a needle nose pliers and a paper clip and started bending the paper clip to create a larger loop at the top and a smaller loop at the bottom. The overall paper clip shape is a C shape when you look at it from the front of the device. And so it took a little while to figure out exactly where to position it. And so we drilled a hole in the side of the wood and put a panhead wood screw in there to hold the paper clip in place. And then we put a little loop at the bottom and put another screw there to just ensure that the paper clip would be nice and secure. And so once we had the paper clip in place and it was connected, we put the ball in and tried to make sure it was lined up correctly so that the launcher would hit it. And at this point in time, we still have the PVC on there. We're still looking at experimenting with the PVC. We will eventually remove that because it actually ended up causing, with the paper clip, ended up causing the ball to sort of launch to the side. So we'll do a quick launch here and just check it out. So we decided to do some field tests, and we recorded the distances and the height and the different angles and positions that we launched the ball at. And we did this a number of times. We had a little sand trap set up so we could see exactly where the ball had landed, and then we recorded that and tried to figure out if we could improve the launcher in any other ways. And we noticed that there were a couple of opportunities for improvement, so we went back to our drawing and made some adaptations. Finally, we were looking at our design, and we discovered that as we launched at steeper and steeper angles, like right here, when we're setting the device at steeper angles at like 50 and 60 and 70 and 80 degrees, the top section of the device tended to fall backwards or lean backwards. And so when we were launching the ping pong ball, it became it was hard to reliably launch it without that top part moving. The other thing we noticed is that we wanted to grab the launcher to stabilize it. We tended to want to grab it right here, which is great, except for the fact that when the aluminum bar swings back, it can smack your hand on this part right here. So we wanted to make sure that wasn't going to be a possibility, and we wanted to find a way to keep this top piece down. So what we decided to do was to incorporate these features, or create these features. So we have a bolt that we've cut a little bit short, goes right here. It's a 5/16 bolt, and we have a nylon sleeve that goes around it, and that keeps the launching apparatus or the top piece from coming back or leaning back when it's at a steep angle. And then we used a 1/2 inch plywood
to create a cover for the spring assembly area. And we cut a hole out in it so you can still access that bolt if you need to loosen or tighten it. And cut a hole here, or cut a half a hole here to do the same with this bolt. But this way you can pull the launcher back, and there's no chance of any kind of being pinched or caught in any way. And so those are the main innovations on the launcher there.
So now I'm going to spin it around so you can take a look at it from a number of different angles. You can see there are 1, 2, 3, 4 main pieces of wood that hold the cover in place, and then we have our bolt there with the sleeve. Okay, so now we're going to see what we can do to improve the launcher and make those changes. You can already see the bolt with the sleeve is in place there to prevent the launcher from coming back too far. Now we're going to measure the top part of the cover that's going to go over the spring assembly. That'll be 6.5 inches wide, and then we've got a 1 inch spade bit that we're going to use to drill out the holes for the bolts. So that's the center bolt and the spring bolt. And so now we're just marking the positions. We're drilling those bolt holes out and cleaning that off. We're going to set our fence up, and that fence will allow us to use the circular saw to cut a nice straight edge. And we used the piece of wood there to make sure that the fence didn't interfere with the clamps. So now we're just trimming it down to the right length and cleaning off the edges with a file. And now what we've done is we're cutting the side pieces. Those are 1.75 inches high, and they go all the way around the edge of that box, and we're cleaning those pieces off. And they're 6.5 inches wide then there's one piece that's 13 inches wide, and that's the piece that runs along the long edge. And so now we're just clamping those in place. We've already marked them 3/8 of an inch up. We're drilling our holes with a 1/16 inch drill bit. And now we're just putting 1.5 inch panhead wood screws in. And we screwed our top piece on already. And now we're going to put the bottom piece on. Just lining that up using the clamps to hold it in place. And again, 3/8 of an inch up. And we're just putting those screws in. Now we're going to go ahead and put the top part on. And we're again pre-drilling all those holes and using our panhead wood screws, putting them in. So we have everything lined up. The hole in the center wasn't as clean as we like, so I'm going to take a Dremel and go back and clean that hole up, make it a little bit smoother, so that it's sure that we're out of the way of the bolt below. So we're going to take the cover back off, and we're going to assemble the hardware inside the device again. You've seen us do that before, so that's not anything really new. We're just tightening down our bolts and making sure everything's secure. And then we're going to tighten down all the screws for the new cover on the launcher and make sure that it works. Now we're shortening the bolt that we need, which was that little green bolt that was in the drawing, and cleaning it off with a file. So that's just going to make sure that the major piece doesn't fold back when it's at a steep angle. And so that's the part right there. And there's the original bolt down below. We've got our paper clip that holds the ball in place and keeps everything lined up. And again, we've got our countersunk holes. We can drop the vise completely flat. And I'll just turn it around here for you so you can see all of the different components and how it looks and works together. And we'll set that angle bolt in, and then we'll put the bolt and its sleeve, the other bolt and its sleeve in place. And so now we're going to test fire it. Put a ping pong ball in, and we got a successful launch. So now we're going to go test it in the field. So we've got our projectile launcher set up, and we have our numbers indicating the height on the back and the black plastic there, and then we have our tape measure so we can measure how far it goes, or our range. Initially, we're going to set at position 4, which is the 4th position back from horizontal, and angle 20. So 20 degrees. And you can see where the ball lands out there. We went out and measured it in the sand. The sand kind of lets us see where the ball landed. So we're at position 30, or I should say 30 degrees, and the same position, so the 4th position down. And now we're at 40 degrees. Again, seeing that the ball is going up higher. Now we're at 50 degrees, and again, the ball keeps going higher, and it's the range of the ball is decreasing and the height is increasing. And so now we're at 60 degrees. And as we go higher and higher, the ball tends to sort of veer off a little bit. Now we're at 70 degrees, same position. The ball completely goes out of the screen, and again, it's not quite as far away. And now we're at 80 degrees. So we're going to take a look at precisely measuring exactly how high the ball goes. The sand measures our range, and we can slow the film down and see that the ball went just below 3 feet. The top of the paper is exactly 3 feet. So the ball was about 2 feet 10 inches on that particular shot. So we're going to try another one. And on that one, again, it was at 20 degrees, position 4. We can see the ball goes to about 3 feet 4 inches on that particular shot. So that allows us to see the height, and we can use that in our calculations. Now we're going to see if we can use this information to knock down a tower of cups. So we've got it all set up. This is position 4, 20 degrees. Yeah. Only 3 tries.